Any other questions?
And thank you, Mary.
Yeah, absolutely. Thanks for having us.
Okay, so we are a few minutes ahead, so we can maybe take a 5 minutes break, and then we can have our last speaker for today, or we can keep pushing, maybe finish early. That's another option also, you think? Yeah, okay, let's maybe start. Yeah, okay, so I would like to introduce our last speaker of today, Oliver from DLR, the German Aerospace Corporation, and he will be giving a talk about a proposal for a project to explore both the strengths of SysML v2 and the strength of ontological modeling together in a case study from the domains of DLR. So with that, the floor is yours.
Yeah, thank you very much. And thank you for the opportunity to share our thoughts about the next steps in model-based aircraft systems design. A few words about DLR, German Aerospace Center. We are having more than 50 institutes and institutions, and in my talk today, it's about our institute, the Institute of Flight Systems, especially in the field of flight control systems design. Yes, we applied MBSE with SysML v1 in many research and industry projects so far, and is a solid foundation for us, but has also clear limitations, and that is why we want we plan a new initiative where emerging technologies can solve those limitations so far. For this, I want to give an overview over the motivation behind this work, or this planned work. I want to introduce the core technologies, give the value proposition for this approach, and the goal of this talk is to engage with the community, to invite feedback, and also looking for collaboration opportunities. So, flight control systems is a prime example for the evolving aircraft system technologies so far. And there are different drivers for this increasing complexity. First of all, the technological innovations. Here, for instance, multifunctional movers, new functions like load alleviation or flutter suppression, considered early in the design already, and also power and fly-by-wire systems in terms of more all-electrical aircraft. Then there are also market demands, for instance, increased passenger comfort, cost reduction and efficiency of the systems, and sustainability and CO2 reduction. Last but not least, there are also the regulations, for instance, coming from the politics, the environmental regulations, or new and updated certification requirements from the authorities. So, and these modern flight control systems have this increasing complexity. So, we used already a few years ago the document-based development processes, but it's clear that it was not solving the problem of this increasing complexity, because we had fragmented workflows, isolated teams, and also inconsistent and outdated documents, for instance. So that is why we came to the model-based systems engineering approach, because it promises as structured models instead of unstructured documents, and more collaboration between the teams by the single source of truth approach, so on. You know that all. MBSE is for us a comprehensive approach by having tool, language, and method, and addressing this increasing complexity problem. So we have a lot of experience. I mentioned it beginning with SysML V1 in the flight control systems development in different real-world applications, commercial aircraft, small aircraft, unmanned aircraft, military aircraft, but also space systems. And we applied it over the complete development lifecycle, requirements engineering, capturing, tracing, system architecture design for the definition of functional logical architectures, interface definition, but also for the development of innovative system technologies, not only actuators, but also avionics systems. And in the field of integration, verification, and validation by integrating, for instance, simulation tools. Yes, and these experiences have shown that MBSE has this potential to improve the clarity, communication, and collaboration in our interdisciplinary projects. Flight control systems are also safety critical systems. So our MBSE approach was not only was also covered with MBSA, model-based safety assessment, especially for the improved system architecture design. We have a process here for the continuous mapping of the different steps of the different aircraft standards so far. We developed, used, and implemented different profiles for MBSA. For instance, functional hazard assessment, the RAML profile for the risk and analysis and assessment, and the SCPA. It was also supported with our own analysis tools. For instance, we have a tool for the calculation of the reliability for the different system architecture candidates. So this integrated approach, together with SysML V1, helps us in designing safe flight control systems. But the question is it enough for the future? Because we identified different challenges with this approach. First of all, we have isolated and distributed models, which leads also to inconsistencies and duplicated work so far. Also, the reuse of models are difficult. This is especially a problem if we want to adapt or scale these solutions, which are becoming then more time intensive. And also the handling of large models was is a critical issue. We have also interdisciplinary gaps. Domain experts are not the experts for this modeling approach, of course. So it's not intuitive also for them to understand these models. Also, the model elements, there is a different understanding. And especially SysML V1 lacks of formal semantics and also the semantic integration across the domains. This is especially a problem for the system-wide reasoning and automation. So, and last but not least, the interoperability is also difficult, especially in distributed teams and organizations. And that is why we need an enhanced approach which addresses these current challenges and with added semantics, interoperability, and version management. So, yes.
Can you go back to the slide? It seems like the challenges that you put on the right, the isolation, the reuse, and the large models, they're problems of modularity or lack of modularity. And it seems to me that modularity is something that, in effect, is independent of which technology you use. I mean, in your case, you see SysML v1, but you could use ontologies and have poor modularities, just like you could use, programming languages and whatnot, right? So have you recognized modularity as a challenge that needs to be addressed in some form or not?
Yes. It's of course it's always a problem with modularity. I have not listed it up because these are just only few examples for that approach. Okay. So the new approach is enhancing MBSE with SysML v2, semantic modeling and integrated model management so far. SysML v2 offers a more dynamic and model-centric approach and is fully tailored for systems engineering. It's clear that SysML v1 is also tailored for systems engineering, but has some kind of gaps. We want to use also the OML, which offers a traceability, consistency, and the system-wide reasoning, and also shared understanding via formal semantics, and offers also the possibility to have knowledge graphs which can link the life cycle phases and domains together. Last but not least is also the Flexo MMS for the version control and the collaboration across teams, and for the efficient governance of the evolving system models. So, and by this approach, we could unlock the path toward scalable, connected, and more dependable system development. So now I want to deep dive a little bit into the core technologies. SysML v2 is a next generation system modeling language. It's based on the kernel, which defines the core structure, semantics, and notation. It provides a unified textual and graphical representation. It has not only enhanced expressiveness, but also improved consistency and usability, and it supports reusability and extendability through library approach. Important key feature is then the SysML v2 API, which offers a seamless integration opportunity and the interoperability, the model management and queries, and it supports for the toolchain integration. So, and in our approach, the SysML v2 ontology is the foundational language for our system modeling, and the SysML v2 REST API is then the basis for the automation, integration, and the versioning. So coming to the second technology, the OML, we have here we have not identified. These are the different the main benefits we see here of OML. First of all, the expressiveness. We can define description logic-based vocabularies. We can have custom rules. We can use reusable modeling patterns. We can have the reasoning by having logical consistency checks, simplifying queries. Important also for us is the componentization. We can structure our information by the methodology. And last but not least, the extensibility by integration of external information. What we heard in the talk of Margaret is the SysML v2 ontology pipeline, which is an important key feature for us, because we could use then the SysML in OML representation in our projects. So, and although we have then not only the SysML v2, we can also have then the benefits of the OML.
Are you going to explain what you mean by componentization by structure? information by methodology?
Yes. So it means that that you can define your own methodology based on your domain experts, for instance, or system engineering process, and this is the idea behind.
What I'm not sure I understand is what do you mean by what is being componentized?
I think what this means is when you have when you define a methodology with a vocabulary, and then to actually use it, you can define methodology viewpoints that kind of that would organize the information into modules, into namespaces, into files. It's part of the tooling that you can layer on top of vocabulary. For example, you can say all the components will be in this namespace, all the interfaces in this namespace. When we talk about interfaces, they go here. So you can actually structure, you can define these viewpoints and put them into the tool such that when engineers are authoring information, the information can get organized in modules.
So, and the last technology is then the FlexOMS is a component in the OpenMBE framework, which is which enables engineers to work in the language of their choice. And the FlexOMS is under development. We heard it before, and the basic idea is to have the SysML v2 REST API. To store then the SysML v2 models in an RDF graph so far. And by that we can take the different features of the FlexOMS with a different SparkQL and graph store protocol endpoints for the different model operations, like update, load, query, and also to manage the RDF graphs, for instance, with branching and versioning. So, and the basic idea is then to use the SysML v2 ontology, utilizing the FlexOMS and the SysML v2 REST API to streamline the model versioning, querying, and the collaboration. So coming back to the bigger picture, the invention goes with our enhanced MBSE approach is to explore the synergy between SysML v2 and OML to enhance MBSE and foster innovation in system design, use FlexOMS as a central platform for integrated traceable model management, and to enable faster, more reliable development through this cohesive digital engineering environment. Also, we want to establish a unified approach to improve model interoperability and system traceability. So our expected outcomes is this unified modeling framework. We want to have also a semantic knowledge graph, and we want to derive also integration best practices and the collaborative development practices. Our target stakeholders are the technology providers, the system engineers, industry partners, and research institutions. So I want to summarize then the value proposition. We want to extend the capabilities of OML to the application of SysML v2 to show the or to broaden the system modeling applications. We plan to demonstrate and validate it with real-world projects to enhance the consistency, efficiency, and traceability. We want also to demonstrate FlexOMS in managing these SysML v2 models, proving its practical value, and to highlight Flexo as a key tool for the collaborative version system model management. So last but not least, also the system seamless integration as a combination of these three technologies as a streamlined modeling approach, and also to have an interoperable ecosystem with other tools. So our idea is is an envisioned application case which covers an important MBSE challenge for us, namely the ensuring the scalability and performance of SysML v2 models in large complex systems. Therefore, we want to address the commercial aircraft application with a high aspect ratio wing and multifunction movables. We want to model electric, hydraulic, or hybrid actuation systems. We have here many information from different projects so far. We can address then the collaboration of system engineering experts and domain experts, and it has also the opportunity to integrate safety methods, domain tools, and other data, test data, for instance. So I want to close with a call to action. First of all, unlock the new potential. So let's demonstrate how OML and Flexo can, together with SysML v2, manage these models in real-world projects. Then we want to explore potential synergies between these three components to address the key system modeling challenges and looking for the collaboration opportunities. And last but not least, together we can drive this innovation in system modeling.
Thank you so much, Oliver. Is there any questions from the audience? There is one from Nicholas.
So described earlier that you're using the SysML v2 to OML mapping that Maged was describing earlier, right?
Mm-hmm.
And then you had a chart also that showed that using Flexo, we effectively export a SysML v2 model to RDF, right? So my question is Flexo producing an RDF model that is an instance of the mapping from SysML v2 to OML?
I can take this. Yes, it will be. Remember, this is a proposal still. It's not something that Oliver has already done. He's proposing to make a project that will test that these tools together.
This is exactly what Margaret says. It's a proposal. We want to address this, and this is one of the questions we want to answer. So we don't know now.
Yeah, I think
so
it would be.
We have this representation then.
Right. It would be
the intent is yes, because the Flexo will structure the RDF based on the ontology that was developed by OpenCaesar.
Okay.
So the idea is to enable, and they have a plan also to implement the SysML REST API by delegating to Sparkle updates.
Okay.
Yeah.
So I have a related question about, you mentioned like using Flexo for version management, right? And this morning there was this presentation by you guys like Leonardo about federated, effectively, vocabularies, right? Like management, architecture, things like that. So have you guys also thought about how you will deal with the version management of federated vocabularies or federated models, where you mentioned like, distribution and multiple teams? You could have effectively fragments of models defined by some teams, and like what Leonardo was describing, some kind of like carefully orchestrated push-pull type workflow to use a version from some supplier in the customer somewhere or something, and doing some analysis. Are you including those kinds of federation and into your version management vision?
In general, yes, I would say, because the approach is already, I would say, shown in the OML tutorials, I would say. So, and the idea is then just to use then the SysML v2 language in OML with this approach. So, and what does it mean then in the end? Store it then in RDF via this approach. This is what we want to investigate.
So
What
my
are the
understanding,
limitations and so on?
I'm not sure if somebody from Flexo is still online. My understanding is that Flexo provides its own version control mechanism within as a layer in the RDF representation. So they will let you make commits, and they track the commit like hash codes in the RDF database, such that you can make queries that are on versioned information.
What maybe Margaret? So from my understanding, the Flexo MMS is a version control system for graphs so far.
Mm-hmm.
And so what does it mean then for the partial models? I don't know. So because in the end, partial model can also be transferred in this RDF graph, and in the end, one can integrate different RDF graphs with this different queries.
I also think this version management is inherited from the SysML v2 API itself, which also talks about version. There's a scheme of asking for versions in the REST API so they're implementing that protocol that was in the spec. However, like all these use cases are new, and this project will actually explore it and put them to the test so that we can report on them.
But see, can you go back to the chart that showed like the application to this aircraft thing? Right, so there could be multiple domain experts, right? Like in power, thermal, navigation, you name it, right?
Yeah.
Structural integrity, vibration, and things like this. So is your expectation that all of these engineering models will be in SysML v2, or could there be some models in some other tools?
They will be in other tools. I can't imagine that the other domain experts will transfer their results into the SysML v2. So this is one of the questions: how to integrate all these different, I would say, analysis results into an, I would say, bigger system model.
It's maybe more than the results, right? It's maybe like the configuration of the analysis itself, even the version of the analysis, right? And Yuta was describing some of that in his presentation, right? So he's kind of takes a broader scope of versioning, basically everything that engineers care about to produce at the very long chain of steps some useful results.
Sorry? Yeah.
No, you are talking about like you imagine like there'll be different domain experts and different models created in different systems. And you talk about like integrating, how to integrate all these, the big questions. So have you explored any ways to solve?
Not yet. From our experience, we have the MDO processes. We have centralized models for that, where all the results are stored. So this is one approach we have covered in DLR. But integration with system engineering models, I would say, is not yet really covered. So, yeah.
And this in OpenCaesar approach, the way this could be tackled is that every one of these disciplines can be represented with ontologies. Of course, without doing any effort, these are silo ontologies. The next step will be integrating, i.e. creating ontologies that integrate ontologies, the other ones, saying how they correspond to each other, how they map, creating trace relationships, or saying this thing known by this name here is the same as this thing. So this needs to be an extra effort on top of just domain modeling in every one of the to arrive at that integration. And then when you actually create data sets in each one of these disciplines, maybe by different authorities in different repositories, then you as the program who's using all these things need to decide how you need to architect an integration plan for them, where you may have intermediate steps of integration. First, let's integrate electrical with mechanical. Next, we add thermal, and then we do this. And every one of these integration steps can become a repo that has its own vocabulary, that imports the downstream datasets, and itself become a component into an upstream integration point, leading to the final most integrated dataset that has everything.
So it needs some kind of conceptual, lineage.
Integration itself is an architecture that needs to be done in addition to the discipline architecture itself.
I will also, again, push back on the idea of a model of everything.
Yeah.
Because I don't think that's practical or ever likely to happen. Not going to replace our CAD tools with ontological models, right? We need to find where the boundaries are.
Yeah.
Right.
Right.
Model what we need to model, use the existing tools for what.
Absolutely. Yeah. Yeah. Like integrating tools doesn't mean getting everything in those tools into ontologies.
Yes.
Getting what matters, what you care to analyze is what you pull out of the tools and represent ontologically, leaving the details that doesn't matter to your analysis behind.
Right. So you started a use case and then you.
Yeah.
If
is many pieces of information. So yeah, you can have billions of relationships. But if I were to say that node then represented all the metadata, all the whatever, some table that had 200 and 300 columns out of it that I put into that node, you will lose. The question becomes, what do you really want to solve? And once you know that, then you're designing your ontology to meet those needs. You do not need to boil the ocean. You just need to be able to solve for a finite set of questions and know that that is what the. It is not meant as a tool to duplicate data. You'd just be creating huge data lake house. And you'd run into sync problems. You'd run into problems.
Okay.
It is like an enterprise
Level.
architecture problem that one needs to think about it this way.
Yeah.
Okay.
Maybe one comment from my side. What I have seen in the past was that there were built up big models, simulation models somehow, which should answer many questions. So, but this is not the goal, because a model is to answer one question or maybe a few questions, but not what you said, ocean.
Yeah, boil the ocean. Yeah. All right. Thank you so much, Oliver.